I'd like to welcome you to today's webinar hosted by the Building America program. We are excited to have Eric Whirling here today to introduce the Building America Technology to Market Roadmaps that will serve as a guide for research, development, and demonstration activities in the coming years and result in an integrated research to market plan in 2015. He will also tell you about a new request for information just released that is soliciting feedback about the technology roadmaps for moisture-managed building envelope, comfort or HVAC systems, and indoor air quality. Also, we have experts from 3 Department of Energy national laboratories to answer questions about each of the technology focus areas. Before we begin, I'll quickly go over some of the webinar features. For audio, you have 2 options. You may either listen through your computer or telephone. If you choose to listen through your computer, please select the mic and speakers option in the audio pane. By doing so, we will eliminate the possibility of feedback and echo. If you select the telephone option, a box on the right side will display the telephone number and audio pin you should use to dial in. If you have technical difficulties with the webinar, you may contact the GoToWebinars help desk at 888-259-3826 for assistance. If you would like to ask a question, please use the questions pane to type in your question. If you are having difficulty viewing the materials through the webinar portal, you may find PDF copies of the presentations at the website listed here, and you may follow along as our speaker presents. Today's webinar is being recorded, and the recording will be available on the DOE YouTube channel within a week. We have an exciting program prepared for you today that will describe the integrated Building America Technology to Market Roadmaps that will serve as a guide for research, development, and demonstration activities over the coming years, and a request for information just released that is soliciting industry feedback on the roadmaps. Before our speaker begins, I will give a short overview of the Building America program. Following the presentation, we will have a Q&A session, closing remarks, and a brief survey. The U.S. Department of Energy's Building America program has been a source of innovations in residential building energy performance, durability, quality, affordability, and comfort for 20 years. This world-class research program partners with industry to bring cutting-edge innovations and resources to market. Building America is supported by 10 industry research teams and 4 national labs. Each of these teams and labs partner with dozens of industry professionals, including builders, remodelers, manufacturers, and utilities. The best and the brightest in the residential buildings industry can be found here. Building America uses applied research to deliver building science solutions using a 4-step framework. These innovative solutions are tested in homes to develop proven case studies of success the market can point to. Building America provides the tools the building industry needs to ensure the innovations are applied correctly, always keeping an eye on energy performance, durability, quality, and affordability. The final step, infrastructure development, is the conduit to getting innovations to the marketplace. Building America research focuses on how the components of new and existing homes work together through systems integration. As the market changes and evolves, so has the direction of our research in order to add value and drive changes in performance across the residential building industry. In addition to technical challenges we have been addressing for decades, there is now a need to understand market transformation issues such as valuation of energy efficiency. In the 20 years of Building America research, we have spearheaded combining ultra-high efficiency with high performance in both new and existing homes, and we are consistently achieving this challenging task. For example, in 1995, a typical home used 3 times more energy per square foot compared to today, and indoor air quality, comfort, and durability problems were common. Today, a home built to DOE Zero Energy Ready Home specifications uses less than half the energy and is more comfortable, healthy, and durable. By 2030, Building America will demonstrate that new and existing homes can produce more energy than they use. Do you want to know more about these proven innovations? The Building America Solutions Center is your one-stop source for expert information on hundreds of high-performance construction topics, including air sealing and insulation, HVAC components, windows, indoor air quality, and much more. You can find it by the URL on your screen or by searching on Building America Solutions Center. Also, the Building America website provides information about the program, the latest top innovations and case studies, and there you can also subscribe to the monthly newsletter. And now, on to today's presentation. Our webinar today will introduce the new Building America Technology to Market Roadmaps and a new request for information to gather industry feedback on the 3 roadmaps in the areas of moisture-managed building envelope, heating, ventilating, and air conditioning, and indoor air quality. If you would like detailed information about any of these efforts, or if you're interested in collaborating, please feel free to contact our panelists. Our speaker today is Eric Whirling, who directs Building America research efforts on behalf of the Energy Department. Formerly, he worked at the Environmental Protection Agency as the National Coordinator for EPA's Indoor Air Plus Home Labeling Program, created EPA's Healthy Indoor Environment Protocols for Home Energy Upgrades, and managed development of the ASHRAE Indoor Air Quality Guide. He also helped to build the Energy Star for New Homes program. Eric is a member of the ASHRAE Standards 62.2 Committee and has served on the boards of ACI and ResNet. And if you've ever attended a Building America technical stakeholder meeting, you may have heard Eric performing one of his original Building America ballads, accompanied by his guitar. Today, Eric will introduce a new Building America Research to Market plan and tell you about a request for information just issued by Building America to gather industry feedback on 3 technology roadmaps addressing technical challenges in the area of building envelope, heating, ventilating, and air conditioning, and indoor air quality. The feedback received will be used to guide the Building America Research to Market plan and develop future funding opportunity announcements as Building America works to meet long-term energy efficiency goals. Also here today are experts from the National Laboratory supporting the 3 technical areas who will field questions during our Q&A session. John Winkler is a senior engineer at the National Renewable Energy Laboratory, where he focuses on residential HVAC systems, dehumidification control, energy modeling tools, and BOP development. And Rel serves as the technical lead laboratory for the Optimal Comfort, or HVAC Systems Technology Roadmap. At Lawrence Berkeley National Laboratory, Ian Walker studies energy use, ventilation, moisture, performance simulation, and diagnostic issues in homes. His current research focuses on retrofits, zero and low energy homes, and HVAC systems through field and lab evaluations, modeling, and standards. LBNL serves as the technical lead laboratory for the Indoor Air Quality Technology Roadmap. Roderick Jackson leads the Building Envelope Systems Research Group at the Building Technologies Research and Integration Center of Oak Ridge National Laboratory. His research focuses on the integration of technologies and best practices that maximize cost-effective energy efficiency in homes. He also leads an Oak Ridge initiative to integrate building technologies, advanced vehicles, manufacturing, distributed clean power generation, and novel energy storage that will enable transformational breakthroughs in energy generation, use, and management. Oak Ridge is the lead laboratory for the Building Envelope Technology Roadmap. And with that, I'd like to welcome Eric to start the presentation.
Thank you, Gail. Let me push the buttons to get the presentation up. There we go. So hello, everyone. Thanks for the introduction, Gail. And I'm looking forward to telling you about the the market roadmaps that we've been working hard to develop over the last few months, and more importantly, excited about what comes after we get through this RFI. We're looking forward to refining it based on public comment, and then feeding it into our development process for future funding opportunity announcements. And hopefully this new strategy that clarifies specifically our objectives in a bunch of areas that I'll describe later in the presentation, will help make it much more clear what types of activities we're doing with Building America, how industry stakeholders can participate actively, and how we can solve the problems that prevent the adoption of higher performance, energy efficient, and healthier systems in our homes over the next decade or so. So with that, I'm just going to dive into my prepared slides. My strategy for the webinar today is to get through the slides as quickly as I can. Many of you who've heard me talk before know I can talk a lot, so I'm going to try and temper that a little bit, get through the prepared slides as quickly as possible, and leave at least half of the session, if possible, available for questions. So with that, I'd like to start with just a news flash. We already know how to build zero-energy homes. Many of you are probably not surprised by that statement, but just a little tongue-in-cheek recipe. Here is how we do zero-energy homes already. First, you construct the perfect envelope. Second, you install high-efficiency HVAC ventilation appliances and lighting. Third, you add some energy generation to make up for what you haven't saved with efficiency, and you add conservation to taste. And here's an example of a home that is actually a net positive energy home at this point. This is a test home at the NIST laboratory in Maryland that was designed, incidentally, by one of the Building America participants. So with that, we're shooting for zero. Building America is focused on helping to develop the technologies and demonstrate them and overcome the market barriers to them so that mainstream builders, both production builders and affordable housing, public housing, etc., and also the existing home retrofit community can get closer and closer to zero, and then over the next decade we expect the prices of renewables to keep coming down so that the actual zero-energy homes will be achieved over time with our contributions. So it looks like we're pretty squarely on the road to zero-energy homes, which sounds great, but in theory there is no difference between theory and practice. In practice there is, and that's one of my favorite quotes by Yogi Berra. There we go. I'm struggling with my animations. Okay, so the road to zero energy is, we're on that path, but how many actual zero energy homes are there? Well, I can't find an official count. If anybody has one, please email me or submit that through the RFI process or whatever. Our best guess is that it's probably less than 500 homes to date in the U.S. that are actually net zero or net positive energy homes, and that's a pretty small number compared to all the rest of the homes. So if we know how to do zero energy homes, I think it's important for us to know why we're not seeing a whole lot of them in the marketplace, especially in the context that we're actually seeing hundreds of thousands of PV installations on roofs over the last couple of years. So there's an awful lot of generation going into houses. Why we are still not at net zero energy homes at a large market level. And the reality is that it still costs more, especially first costs, to get to these higher levels of performance in homes. The infrastructure favors low first costs. We also have some other issues that have been identified over the last 15 or 20 years, which is one of them, and one of the most important ones, and we'll talk a lot more about this issue as we go on today, is that many of the technologies for improving the performance homes are actually pretty risky from a business perspective and sometimes from a technical perspective. We also have issues like the workforce is not skilled enough to manage all the complexities of delivering a zero energy ready or a net zero energy home. And finally, the utilities are worried about what will happen when we start to add generation capacity in a decentralized way on top of roofs all around the country. What will happen to the reliability of the utility grid? These are really good questions and concerns that the grid-connected net zero energy community needs to address over the next few years. So we have some fairly significant remaining challenges that prevent us from driving fast down that road to zero energy homes. So I kind of liken it more to a dirt road that we've started. Now the question is, how do we pave that dirt road and get us to zero energy homes, hopefully within my career over the next 10, 15, 20 years. I'm about ready to retire, I'd say, in 10 or 15 years, and I'd like to know that we accomplished most of our job. Now, one question that sometimes comes up, especially when we're doing analysis about what are the optimum ways to get to zero energy, the question of whether we should focus more of our efforts on energy efficiency or renewable, and I'm not going to try and enter into that argument. We don't really, it's really a falsehood that we face that road, that choice. So here's another Yogi Berra quote I like: if you come to a fork in the road, take it. What I mean by that is that we're going down this road towards zero energy homes, and it's under construction, and we are working on both the energy efficiency issues and the renewable energy generation issues. And there's no reason why we should decide which one of those two is important. They're both important. So getting to zero energy homes, the overarching strategy for DOE is that the energy efficiency goal for the homes, buildings in general, is 50% savings. And we've set that based on a benchmark of what the code level performance was for new construction anyway in 2009 with the IECC. So 50% savings compared to that 2009 IECC is our technical goal. We know that it's technically feasible. It can be challenging to find the optimal, and there's also a bunch of market barriers that we're focused on. So that's what Building America and the Zero Energy Ready Homes program are doing collectively, and we'll leave the other 50% of the getting to zero energy homes up to our counterparts in the Sunshot program. But since I'm mentioning them briefly, their objective is by 2020 to get PV installations to be cost competitive with existing central utility supplied power. And therefore, they're focusing on the biggest cost barriers right now, the balance of systems and the soft costs, like non-technical costs, such as permitting and labor costs and things like that. So that's the big picture about what we're doing to get to zero energy homes at DOE. And the rest of the presentation, I'm going to dive into the issues that we're tackling with Building America, and then also, of course, with the market-facing aspects of the zero energy ready home for new construction. So this constitutes what we're sort of informally calling V2 of the Building America program. A bunch of stuff has changed in this iteration of the program, and with this RFI and a host of funding opportunity announcements that we'll be doing and awards that we'll be doing over the next few years, this is a summary of the big changes that we've brought into the program. First, we're focused more tightly on the biggest energy consumption and the biggest issues that we have to tackle technologically in order to get to that 50% savings target for homes. If we're going to get 50% savings relative to 2009 code levels, and we're going to do it all with energy efficiency, there's a long ways we can go with appliances and lighting and miscellaneous electric loads, but we're not going to get the full 50% savings if we don't improve the efficiency of the heating and cooling systems, which also include the performance of the envelope or enclosure. So that's our focus over the next 2 to 3 years. That doesn't mean, and as long as the impacts will be, the projects that we'll be funding in this area will be going on probably for the next 3 to 5 years. Now, we are focused mostly on these 3 aspects of getting heating and cooling energy to be optimize and as low as possible? How do you deliver high-performance envelopes to the marketplace such that they achieve those performance targets and they do it in a way that doesn't cause problems for comfort or indoor air quality or durability in the homes? We also are going to need to optimize HVAC systems, and we need more expanded IAQ solutions to keep the homes healthy as we build them more tightly. A little bit more about that stuff in a few slides. The other things that we're doing is we're changing the way we do funding opportunity announcements. I'll show you a slide that gives you a little bit of a graphical view of how we do those funding announcements. But in short, we are planning 3 years of funding announcements sequentially, 15, 16, and 17. We're just about to award the FY15 funding opportunity announcements. Some of you on the phone may have been participants in that process. And then what we're doing with the roadmaps are going to work up to the development of the FY16 and FY17 FOAs. So a little bit more about those two things later. We are developing these roadmaps. That's the subject of the rest of this presentation and some follow-on activities that we'll be doing for the remainder of the year. So I won't say anything more about that until we get into them. And that includes stakeholder input through this request for information and also Building America expert meetings that we'll be holding in each of these 3 target areas. So that's a lot of stuff that we've been changing in Building America, and that I'm not even mentioning the Zero Energy Ready Homes program activities that we're doing in conjunction with this, so there's a lot going on. Just to back up real quick to remind folks why we're doing this. We're in the Department of Energy. Energy is our primary focus. It's our primary currency, so our goals specifically relate to energy. How do we demonstrate at scale, based on the activities that we fund, market-relevant strategies for new homes that offer savings of 50% or more by 2025. So that's a little bit more tightly defined goal than what I said before. And then in the existing homes realm, we're acknowledging that we're not as far along, so the goals aren't quite as high in terms of percent savings, although in many cases the absolute goals may, of 40%, for instance, may well be actually bigger than savings that we're going to be able to get in new homes. Plus, the existing homes stock is much bigger than what we might affect in any 1 or 2 or 3 year period for new construction. So the holy grail is in getting existing homes to save 40% or more by 2030. We've phased that in our goal structure, acknowledging that there's a lot of challenges in reaching that goal. So back to Building America, why are we focusing specifically on the energy efficiency? Part of the logic behind that is the energy efficiency in the comfort areas, the envelope and the HVAC. I'm lumping those together. Now this pie chart is based on US EIA data, so it's real data in terms of what the average end-use breakout is for homes today in the U.S. By the different energy end uses. I've deliberately lumped together the HVAC and envelope-related consumption because really they are intertwined. The envelope itself and how energy efficient it is determines what your heating and cooling loads are going to be for the house. And then the efficiency of the system determines for a given load how do you serve that need efficiently. And so those two are just linked at the hip. And a couple other aspects about this problem is that unlike most of the rest of the areas, appliances, lighting, miscellaneous end-use loads, those are all energy-consuming end uses that are produced in a factory-assembled process where the performance can actually be measured before it even gets shipped to the home. It's not the case at all for the envelope or the HVAC system because those systems are assembled for the most part, in in the field. Now, there are some components, of course, that are assembled in a factory, but you don't find out how the HVAC system in a house is going to perform until it's hooked up to the duct in a house with an envelope that's complete. And so we put all those together, and we see that that actually accounts for 43% of the energy use in buildings today, which is over a fifth of the total energy consumption of the entire country. So we've got a very significant, roughly 10% of the total energy consumption in this country is tied up in making our houses more comfortable. That's a big amount of energy, and so this is a big target, and Building America is focused on the system integration aspects of improving the energy efficiency in that really big 10-quad bucket. So that's why we're doing what we're doing, and it drives some of our decisions. This is a little bit of a timeline. It's what we originally called our roadmap. It's really now sort of more of just of an overview of how the technology has evolved and how we've gotten to where we are in the middle of the 5th decade here. And Building America is now focused on wrapping up the high-performance targets for our 50% efficiency goals in these 3 areas over the next 5 years. So that's what we're focusing on today and over the next few years with our roadmaps. The reason I show this graphic, though, is to also acknowledge that those aren't the only energy issues that we're concerned about, but they are the ones that we're focusing the most attention on with Building America. And we acknowledge that by 2020 or sooner, we're going to have to pay more attention to how we integrate efficient water heating and water usage, actually, into the home, how we make our homes smarter by integrating the control and communication across the different systems in a home, and ultimately how well do we integrate the renewable energy generation into the grid connection that is at a house with development of smart meters and grid interconnectivity, et cetera. So there's a lot of issues yet to be tackled, but our focus for the next few years is these 3 areas. So more a little bit about those issues. But first I want to sort of briefly explain how Building America works in the context of these other 2 really important areas. So we can do a research or demonstration project where we're showing that a house can achieve a certain energy savings target, like 30% or 50% or whatever, and we can do it in a cutting-edge, real-world, market player type of a scenario. But how do we deliver those demonstrated and proven home solutions to the market? There's a whole different set of activities associated with that. Building America is involved in some of those, but many of the deployment programs that we work with, like Energy Star, are instrumental in actually helping to get more market growth. So we see an interconnection between the Building America activities, and historically, we might demonstrate systems or combinations of systems that achieve 20% or 30% more or whatever, and we might have done it years before Energy Star, and then Energy Star can help to take those proven solutions into the market with some of the early adopters that started with Building America assistance. And then finally, we see that energy codes follow as the market gets better and better at building higher performance homes cost effectively. So that's we would hope, Building America doesn't drive the codes, but we would hope that as the market gets better and better at delivering energy efficiency, that's a value to the American public, and we would hope that the standards and codes by which the industry is judged will continue to improve so that the public benefits from it over the years. So looking forward, what we see when we look at this chart is that an awful lot of the savings that we can get cumulatively based on previous successes in this chart, but also where we'd like to go with the 50% savings target, there's an awful lot of savings that haven't been realized yet, and so that's what we're focused on, and we're calling this the 50% savings zone. Question is, how do we help achieve that 50% savings? And more importantly, what we've observed over the last, especially over the last 10 years, but we've started to observe some of these things over a longer period than that throughout most of the history of building America, is that the more insulation and the tighter construction that we have, the more we have to manage the moisture flows, air flows, and heat flows in the building in order to get control, to keep comfort, to keep healthy indoor environments. I kind of equate this to, we think about, for instance, in aviation. Imagine back in World War I when you're a fighter ace and you're flying in a biplane with an open cockpit. You take off at 40 miles an hour and your high speed is 100 miles an hour. Back then we had an open cockpit, so we didn't have to worry about the indoor environmental quality of that airplane. But fast forward to World War II, we started getting high altitude fighters and bombers where you can't actually have an open cockpit anymore. Now you have to have a more tightly controlled internal environment for that airplane. And then, of course, we got into airliners in the 50s and 60s and 70s, the space program, and we had to get tighter and tighter in terms of engineering these systems. The same is also true for houses. If we want to get more and more efficiency, better and better controlled performance in houses and other buildings, we have to control the airflows and understand what pollutants are in the environment, and we have to control for it. It's the same kind of problem that the aviation community had to deal with decades and decades before us. So these are the specific problems that we are focused specifically with Building America on solving. We acknowledge that just from a building science perspective, the more insulation and the tighter construction you have, the more likely you are to have moisture problems if you make mistakes in the process of installing the extra insulation and tighter construction. So that's an important issue. The second issue, of course, is that if we're successful at doing the envelope piece and we get the loads for the house down low, then what happens? Well, now our airflows in most systems, most heating and cooling systems in the country are air systems, and so they deliver the cool air or warm air to condition the house, depending on whether you're in heating or cooling mode. And as the loads of the house get lower and lower, the system either runs less or it runs at a lower airflow. And when you have those kinds of situations, now we're worried about getting the flow to all the parts of the houses where people are living and dwelling and occupying. We also have a situation where moisture doesn't flow as rapidly in and out of the house, and so moisture that's trapped inside the house stays there longer, and so now we have a problem potentially of controlling the relative humidity inside. And of course, if that relative humidity gets too high, then the surfaces inside the home become potential condensation risk situations. And finally, of course, just the cleaning or dilution of pollutants that build up inside houses is an important issue that we have to deal with through indoor air quality strategies. So if we don't get better control over these three issues in high-performance homes, then we're going to be stuck with the levels of performance that we have today, because builders today are concerned about getting any more insulation and air tightness into their buildings until we have cost-effective, reliable solutions for managing these issues. So if we focus on those, we solve those. We do have isolated demonstrations of solutions to many of these, but sometimes there are cost barriers, et cetera. So we've got a lot of work to do still. But at least we understand what the problem is better than ever before. So now we're tackling how do we solve this problem as quickly as we can and make it accessible to the industry. So here are the solutions. This is sort of turning the challenges into opportunities. We need high-performance home solutions. For energy-efficient homes, new and existing, we need to be able to have moisture-managed high R envelopes that are less likely to get or stay wet. We need optimized low-load comfort solutions that manage both the airflow and the RH control to maintain adequate comfort or maybe even improve comfort. And we need smarter indoor air quality solutions so that we can do the dilution of pollutants that are generated inside without generally cleaner outside air. We can filter out or control pollutants that come from specific sources within the house, or sometimes pollutants from outside the house, etc. And we want to do it with little or no energy penalty. So we've got some partial solutions, but there's plenty of work to be done in the indoor air quality space as well. So we've got our hands full with these three challenges. But Building America has also been successful at making a lot of progress in each of these areas. So we're confident that we can continue to push this forward and deliver on the 50% savings goal without doing any harm. In fact, we think we're going to end up with homes that work better for occupants, they last longer, and they live better, higher quality of living. So now to the roadmaps. That's the setup. Here's the real deal. With the roadmaps in each of these three areas, we are looking to the specific types of objectives that dictate what we have to put in the roadmap. So we're acknowledging that mass market adoption of high-performance homes is going to require some changes to existing codes and standards for a variety of reasons. Sometimes codes or standards are a disincentive to achieving energy efficiency. Sometimes they don't address some of the concerns and risks that we've outlined before, at least not to a satisfactory level in order to encourage higher performance homes, etc. We also want to be able to manage these risks and do it in a way that's good for business, for the building businesses, and it's good for the outcomes. In other words, better occupant comfort, satisfaction, and more savings. So that leads to the last bullet, which is these solutions have to be practical and profitable for builders and home improvement contractors. So one last thing real quick before we get into some of the details of the roadmaps. There's a color code that we're using within these roadmaps to depict these kinds of activities. The blue bubbles in the roadmaps represent research and development activities that were, or targets, I should say, that we're shooting for. We acknowledge that each of these blue bubbles are an R&D challenge that's remaining. So what do we have to do, invest in the research and development area to solve that particular problem by a specific date or year? Then we have green bubbles, which represent overall, we're just using the term market engagement. What we mean by that is what kind of information, what kind of tools, what kind of guidance, what kind of other types of information are needed to make it easier for people in the industry to adopt the better technologies that are demonstrated through research programs. And finally, what kinds of changes, adaptations, modifications to existing codes and industry standards are needed. I want to stress that we're talking about industry standards in this roadmap. There are no DOE appliance standards addressed in this particular roadmap. So we're really only talking about the industry consensus standards, such as, for example, the ASHRAE standard 62.2, which is the ventilation standard. So, and one last thing about a key to these roadmaps that you'll see is that we've outlined the bubbles with a solid line if the Building America program envisions that we can take a leadership role in pushing forward some of these things. For instance, if it's a blue bubble with a hard line around it, we envision funding some of that research or part of that research with the Building America funding if we get the appropriations that we plan on. However, we acknowledge in the roadmap that this is an industry, a public-private partnership program. It's a collaboration between the government, the private sector, and the industry organizations. So there are some bubbles in this roadmap that we don't expect to be able to lead, but we would like to generate the collaboration that will lead to accomplishment of these objectives. And it's pretty important for us to be able to identify whether or not the Building America program and DOE are taking the lead or on something, or whether or not we're hoping to contribute to or influence an outcome, but we don't have direct control, nor do we expect that it's appropriate for us to have direct control of an issue. So the dotted lines around the bubbles mean that. So let me dive into the three roadmaps in a minute, but first I want to get back to schedule. So this is where we are. I put both the FY15 funded activities for Building America and the FY16 funded activities onto the same timeline here, just in broad general terms. I've got 5 quarters here just so you can see this is the near-term set of activities that we've been working on and we'll continue to work on for the remainder of this calendar year. We are in the middle there at the RFI. We just posted it on Friday, and today's the webinar about it, and I'll get to it later, but just a teaser that we're closing the comment period on April 30th, so at the end of this month we'll close that out. Then what we'll do is we'll process the comments that we get from you all and hopefully a lot of other industry stakeholders through this RFI process, and we'll analyze what kinds of feedback we're getting from industry stakeholders, and then we'll convene some specific Building America expert meetings to discuss each of those 3 roadmaps, and those are going to happen mid-year this year. The results of all of that, both the public comment period and the expert meetings focused on what kinds of changes do we need to make to these draft roadmaps, will lead to a Building America Research to Market plan. We already have a draft, but we're not going to publish it until we've been through this fairly robust stakeholder engagement process to make sure that we've taken into account all the market issues and concerns and stakeholder needs that we can within the objectives of the program. So that we expect to publish sometime in the summer. I'm hoping by the end of August, so that when we start the development of the next round of funding opportunity announcements in the FY16 FOA development process, target issue date for that is October 1st, and so I hope that the plan that results from this roadmap process will be publicly accessible and available to anybody who wants to bid on our funding opportunity announcement, and we'll be able to strategically identify what types of areas in the roadmap are specific objectives that are highest priority for our funding opportunity announcement. So we're hoping that this process will provide much more clarity about what program goals are, not just specifically what energy targets we're shooting for, but also what types of market engagement activities that are most strategic in order to overcome the technical barriers that we have and drive us towards accelerating the adoption and the standardization of the use of the high performance solutions that we develop and demonstrate through Building America and other related activities. So that's in a nutshell what the planning horizon is for the near term, and for the longer term that can extend into the following years. Each of these funding opportunity announcements, the current one, FY15, the FY16 funding opportunity announcement, and FY17, each one of them are fully funded up front for anticipated to be awards of 2 to 3 years. And we're doing it that way for a variety of reasons, but probably the number one reason is that we have to. We've been told that it's required to fully fund these awards, and so that's partly what drove us to having this incremental funded project approach, which is different from the way Building America projects have been funded over the last 5 years. So that's in a nutshell the funding arrangement and the schedule. Now let's talk about the individual roadmaps, the 3 of them. I'm not going to get too far into the weeds. You can read I hope that all of you and many more folks will actually read the roadmaps and give us your comments, suggestions for improvements, etc. But I do want to introduce the basis for them. So the first one, high performance moisture managed envelope solutions. We have plenty of evidence that high R assemblies are going to be needed to get to the 50% savings goals. We also know that well-constructed high-performance envelopes lead to more comfortable, healthier indoor environments in conjunction with indoor air quality and HVAC systems. But we also know that as the temperature differences and airflow control in the envelope gets tighter, we actually have, in some cases, greater risk of what happens if you don't do the jobs well. So we need to help industry to do the job of building high-performance envelopes better, and plenty of evidence of those opportunities and those risks. So we will move into the roadmap itself here. We've divided the envelope roadmap. This is a draft again. We've divided it into 2 different sections. One is specifically targeted at moisture risk management, and the second is about developing, demonstrating, and documenting guidance for the whole envelope solutions that lead to high performance. So again, just sort of a rehash of the roadmap objectives. All this stuff is in the RFI, so I'm not going to dwell on the slide. And here is the draft moisture managed envelope solutions roadmap for Building America. You'll notice that the key that I mentioned with the blue bubbles are focused on research activities. In this case, they are generally research activities that aren't, most of them aren't directly developing new products or materials, with the exception of potentially the material properties measurement that may end up leading to new materials. But most of these are about getting a better handle on how the new materials or even existing materials at larger insulating levels, for instance, or better air control levels. When we're at those higher performance levels, how do they behave? And what kinds of research projects do we need to do in order to better understand that, so that we can provide better guidance to the industry, so that we can help to improve the standards, and in some cases even develop new standards that make it easier for folks to rely on the results that are published by manufacturers and by programs. And then the second, that's the moisture risk management part, and then the high performance envelope solutions have to do with developing the guidance, validating with field performance measurements in real world houses, the solutions that we recommend, and then helping to integrate those solutions into voluntary programs where they get demonstrated, they get some uptake in the marketplace, and ultimately how can we encourage them in consideration for future codes, either by preventing or by revising the codes such as IRC, such that they don't discourage the use of for instance, one example of the discouragement area is when you want to put more than an inch of insulated sheathing on the exterior of a building, now you have some issues that you have to deal with regards to cladding attachment strength and things like that that people haven't had to use before and may not be adequately addressed in the code. So that's just one example. There are others, including fire code issues, etc. And then other provisions of the energy codes as well that may or may not encourage the best performing system. So we'd like to help build support for encouraging the best performing, highest cost effectiveness solutions in the marketplace over the next few years. So in a nutshell, that's a quickie summary of the moisture managed envelopes roadmap. We've got similar type of justification for the optimal comfort systems. I call it that to remind everybody that it's not just an HVAC system, it's a comfort system. We have HVAC systems so that we can achieve a desirable, comfortable environment inside houses. And we can't do that just with a box. We need to do that by optimizing the performance of the entire comfort system, which includes the distribution system, not just the efficiency and control of the HVAC central equipment. So all of these factors are part of what we're calling optimal comfort systems, and in some cases it even expands beyond what's typically available, like for instance integrated dehumidification control. Here is the optimal comfort systems roadmap. We've divided it into two separate categories. One is system design issues, because design meaning how do you design to meet the loads, not just the sensible temperature-based loads, but also the latent loads for managing the energy and relative humidity. And those design standards affect the performance of equipment once they're installed. And as systems get more sophisticated with variable capacity equipment and variable flow air handlers and things like that, we think that the standards need to adopt. We also think that in some cases there are missing standards or missing aspects of standards that could do a better job of helping us to actually define the design criteria and manage to them for issues like comfort, which it's defined in an industry standard, ASHRAE Standard 55, but there's very little actionable information in Standard 55 relative to the performance of residential HVAC systems. And so we need to translate some of what we know and investigate some of what we don't know about how to achieve optimal comfort for occupants in homes. So a bunch of work to do. Some of it, again, just like the envelopes roadmap, we've got a bunch of research activities and objectives identified. We've got some market information-based activities in green, and then we've got standards and codes that we can work towards improving. On the equipment side, there's a set of objectives there as well. Again, they're similar and they're related, but sometimes there are different parties involved and different strategies for the design community versus the equipment performance and the manufacturers. So we've separated those two activities, but they're all part of the same roadmap. And so finally, I'm going to introduce real briefly the indoor air quality solutions roadmap, and then I'm going to open it up for questions. And I'm just past halfway, so I'm going to do this last one really quick. There's a lot of details here that spread out into two different slides. The first is in the IAQ field, unlike the other two areas, we have a bunch of specific risks that don't behave the same. So we've got more bubbles here. There are more different types of indoor air pollutant issues that we have to manage, and so this got bigger than the other ones. we may be able to, with feedback, prioritize some of these things. I hope so, because we probably can't do all of this, but it's a set of objectives to shoot for in order to improve our standards for managing and our systems for managing indoor air quality in homes and doing it reliably, and also to minimize the amount of energy that's used to do that indoor air quality management. So another part of the IAQ roadmap is the smart ventilation systems. Those are specific because they're about controlling existing ventilation systems or improving the ventilation systems that exist, which are admittedly only part of the solution to all that list of targeted pollutants in the previous page. And then finally, the IAQ evaluation, to whatever extent we can help to build the science and the standards basis for making better practical decisions in the design and operation of buildings based on better science. I think anybody who's been at an ASHRAE Standard 62.2 committee will probably tell you that we don't know as much science about indoor air quality as we'd like, and so we have to make some judgments and compromises in the process of trying to determine what the industry standard minimum level performance for indoor air quality ought to be in homes. So in that context, we think that some better science would help us quite a bit in doing a better job at standardizing minimal acceptable levels of indoor air quality and developing the systems that can lead to controlling the indoor environment to better, more health protective, more comfortable levels. So that, in a nutshell, is the roadmaps, and just a couple of slides to tell you a little bit about the RFI itself, the request for information. We've specifically asked these two types of questions in the RFI. So if you decide that you can spare a little time to look over the request for information, read the roadmaps, and get to some comments, we're most specifically interested in general comments about this overall strategy. Are we missing critical technical challenges beyond the three that we have identified? And if you think so, make a compelling case for how we could address it in this context without slowing down our process towards improving high-performance homes. And second of all, do you have any suggestions for how we can implement different activities within the roadmaps? And then more specifically for each of the three roadmaps, if you happen to be somebody who's more interested specifically in one or another of the roadmaps, we would ask you to consider these types of questions. Are we missing critical research, market, or code and standard needs for stakeholders that are going to make a difference in scale adoption of energy efficiency and high performance? Are there sequence and timing issues related to what we've laid out? Is it realistic and logical? What types of industry organizations are critical to our success if we need to collaborate with folks? Who are the folks that need to be in the room with us? And how do you recommend engaging with them? And then finally, do you have any suggestions or improvements that we haven't identified in any of this process? So those are the things we're looking for, and here are the specific logistics. One thing I want to clarify is that the EERE, the Energy Efficiency Renewable Energy Office of DOE, has a system for managing funding opportunity announcements, because that's the vast majority of the types of industry interaction, stakeholder interaction that we do. So when we do a funding opportunity announcement, we have a system for managing the submissions. And rather than developing a completely separate system, we just use the FOA system for request for information. But it's really important that you know that this request for information, which is designated DE FOA 0001326, is not a funding opportunity announcement. You will, by responding to this, you won't get any money from us. It will lead, though, to our ability to better address stakeholder objectives and needs in our roadmaps and our plans, which will lead to funding opportunity announcements in the future. So there's a link there, but don't be fooled by the name of this request for the number of this request for information. To repeat something I said earlier in the webinar, the comment period closes at 5 p.m. Eastern Standard Time, or is it daylight time? Spring forward, yeah, it's daylight time. 5 p.m. Eastern Daylight Time on April 30th this year. That's 3 weeks away or so. And you'll submit your comments to this email address, buildingamericarfi@ee.doe.gov. All that information is available in the RFI announcement itself. You may have gotten an email blurb from the Building America program if you're a subscriber. If not, you can quickly find the links to the RFI on the Building America website. Or you can just go to Google and Google Building America RFI Roadmap, and you'll find the link directly. It'll come to the top. So that's all I have to say. Here's my email contact information if you have specific questions for me about anything I've said today. And we've got a half an hour open for questions. So I'm going to turn it over to Heather and Gail to manage the question period.
Okay, thanks, Eric. And we have time now for a few questions. Panelists, if you could please unmute your lines for the Q&A session. We have some great questions from the audience, and you can submit additional questions through the questions pane on your screen. Eric, I have some general questions for you. You mentioned there would be 3 expert meetings for each of the 3 technology roadmaps. Are these open to the public, and how can we participate?
The expert meetings, in the interest of fitting into a 4 to 6 hour period, a very hefty agenda designed to take public comments and the strategy in our roadmaps to a point that's actionable for us at DOE. We've decided that the only way we can manage that is if it's not a public meeting, and that's a primary justification for doing the RFI itself. So the public's issues are being considered through the RFI, and we're taking them all quite seriously, and we'll analyze everybody's. We'll read every comment and take them all seriously, but we can't handle hundreds of people in the expert meetings and still get the roadmaps constructively improved. So we've decided to limit those meetings to expert meetings. And so they won't be open to the public. So that's we will, however, publish the proceedings of those meetings. So it will be open in that regard. We just need to be focused on getting the job done in those meetings.
And then there was another question from one of the audience members regarding your breakdown of the field assembled systems. Why isn't hot water a field assembled system? The tank or tankless heater is factory assembled, much like a furnace.
Yeah, sorry to interrupt, Gail. That's a good question, and it is a field assembled system. But it's in most cases it's a separate system from the envelope and HVAC, and we were in a position where, with a shrinking budget, we had to make some decisions about what's the biggest challenge that we're going to tackle and how do we focus on it. So we made the tough decision that for the next couple of years, Building America is not going to be primarily focused on the hot water system, even though we acknowledge that it is a field assembled system. So it's a really good question. You may not like the answer, but that's our rationale for doing it this way. That's another reason why, moving forward, we keep it on that generalized roadmap that I showed earlier in the presentation, because hot water systems are still an important energy use that we need to improve in houses.
And here's another question for you, Eric. Please explain about your research, development, and demonstration approach. So this person understands that the national laboratories will be conducting lab evaluations in tandem with the research team field demonstrations. Is that correct? And who will the teams partner with for these field evaluations? You know, how do they find partners for the field demonstrations in existing homes?
Right. Okay. So two questions. The first one, the quick way to answer that is that that the Building America program funding is divided into the direct funding to the laboratories, which we tend to focus on what are their expertise and strength that is not generally efficient to do, you know, through Building America partnership teams, which are things like, you know, lab facility testing and analysis and the development of modeling tools and algorithms and things like that. So that's an example of the lab's role in this stuff. Then the Building America teams that we will be issuing through awards through the funding opportunity announcement process, those are industry partnership teams, and they tend to be more focused on the real-world demonstrations in real homes and, where possible, collection of data that helps us to build on the body of knowledge. Now, if you think about it, it's pretty obvious that the lab-directed activity and the industry partnership activities really are both going to be better off if they're well coordinated. And so we have been taking steps to make that the lab funded activities to coordinate well with and support the teams. So for instance, if a team wants to do a project that's demonstrating a new smart ventilation system, they might want to work with LBL or one of the other labs in using the expertise of the lab to help inform how they do their study design or whatever. So there's a variety of those kinds of examples that Building America teams will be encouraged to do, and the labs will be encouraged to support the teams as well. We structure our funding arrangements with the labs to do that specifically. And then as for how industry teams are formed, in the past it's generally happened where, just like in an a traditional RFP process, organizations that can benefit from working together have informal discussions about what kinds of activities they might want to propose, follow what Building America is doing, like your participation on this webinar, reading the RFI, reading the strategy document when it comes out in the summer, and then finally, hopefully you'll have some pretty clear ideas about what you want to do for Building America and propose in the FY16 funding opportunity announcement. You'll have a team assembled, and then when the FOA itself comes out, you read it carefully and respond, bid based on your team's capabilities. As for who to go talk to form a team, I guess it all depends on what your objective is and who are the best people in the industry to talk to about teaming with. And that I can't, go into too much detail about recommendations for that. But if you have specific questions about who to team with on a specific topic, email me and I'll see if I can help you out. Hopefully that answered that question, or those two questions.
Okay, thanks. And we've got some questions for each of our lab experts. For John Winkler on the HVAC systems, can you elaborate on the part load sizing procedures bubble? Cooling and heating equipment is sized at design conditions to meet peak heating and cooling loads.
Sure, thanks. That's correct. Typically for residential buildings, you size your air conditioner and your furnace based on peak design conditions, which are typically the ASHRAE 1% and 99% conditions. In high-performance homes, as our cooling seasons shorten in length and the shoulder seasons, namely the spring and fall, become longer. It's harder for that equipment to maintain humidity control in the house. And so what we're suggesting here is to do research on how to properly size whole house humidity control equipment to ensure that the humidity is controlled in the house throughout the entire year.
Okay, thanks. And then here's another one. Let's see. Residential HVAC equipment is typically not commissioned after installation, and installed performance can suffer. Is Building America doing anything to address installed performance issues and ensure in situ performance?
Yeah, so initially we had a third section of our roadmap that was entirely devoted to this issue. We then, just due to timing and funding constraints, had to pare that down. We still have one task in there that's related to working with manufacturers to help develop and incorporate onboard automated fault detection and diagnostic tools, and potentially doing demonstrations around this in Building America homes. And that's likely where our research will focus for this iteration of the roadmap.
Okay.
I would encourage those kind of commenters to, this is Eric, to help us build a case for expanding that activity. I mean, part of what went into this is what are the most important priorities for each of these three roadmaps going forward, and we couldn't do everything. There's a lot of priorities that we identified, but we couldn't do everything. So if there's something that we considered but had to sort of put off or hope that somebody else can fund it or whatever, and you think we ought to be making it more central and why it's more important than something else, give us that input. That's what this RFI is about.
And then I've got some questions here for Roderick on the building envelope. In the roadmap, I read that one of your goals was to change existing moisture-related standards such as ASHRAE 160 that are too conservative. Can you discuss your approach for changing these standards?
Yes, and so there is, thanks for that question and that comment. So there is some concern by some of the industry stakeholders that standards like ASHRAE 160 or SSPC 160 are considered too conservative, where walls that we have a pretty good assurance that they are moisture durable are considered, would fail some of the criteria that are existing. And so what we want to do is utilize our research to supplement that process, because that committee, they are refining that standard, but we want to be able to, in a complementary manner, be able to provide the level of research that's needed to be able to make that moisture criteria and standard something that industry would be able to rely on as a standard that they can trust and use to set durability standards going forward.
So Roderick, maybe, this is Eric, maybe we could add to that might include, well, we expect that it will include testing certain types of assembly configurations in a lab setting where you can control all of the variables, and then validating that with and using it to help improve the models. For instance, like WFI modeling, or just the guidance about how to use the WFI tool, and then also inform and coordinate with what types of data about real-world performance do we need in situations where you can't control as many of the variables, and that's where Building America team projects with moisture measurement would come in place. So what kinds of data do we need from those types of activities that will help to inform improvements to that standard that are likely to be accepted by the standard committee? That's how I would sort of, a little bit of clarity that I would add to Roderick's answer.
Yes, and actually the next question is related to that. The question is, how is the High Performance Moisture Managed Solutions R&D leveraging existing field studies and WUFI analysis of attic moisture performance?
And so what we do is we have, because of some of we want to use a combined approach where we leverage some of the laboratory assets, some of the laboratory equipment that can look at the heat, air, and moisture flow through assemblies, attics, and roof and attic systems being one, in addition to walls. We want to be able to use that to complement and add to the research that's been done. There's already been a significant amount of research that's done, particularly in roof and attic systems, that demonstrate there are some challenges. But what we can do is look for solutions, and many times the solutions are environmental condition specific. And so what we would do is be able to work with both the Building America teams to identify the key parameters that we want to investigate, and in combination with field studies, also use laboratory facilities such as lab chambers to broaden the range of experimental conditions that we can test, and then use those experimental conditions. And then use those experimental conditions to validate WUFI models, so that we can get a broader assessment of where these different solutions are viable and where they may be susceptible to moisture durability challenges.
And then here's another question for you, Roderick, about windows. This person says, I read through the roadmap and noticed R10 windows in the plan. Is there new technology available? Otherwise, these would be extremely expensive. Right now, they are available are mostly triple pane. Where do we go from here?
So that's a good question. One of the things that Eric mentioned during his discussion, some of the roadmap discusses newer or existing materials, but then there is a place for emerging technologies that develop. And one of the challenges, how do we, as a program, enable the market adoption of these technologies? Because how do we demonstrate through validation and demonstration of these technologies that they are, one, high performance, you get the savings that you're looking for, and then two, they are moisture durable. And so you're right, the R10 windows, we listed that as an example. I think you're referring to on page 17, where we say as emerging technologies such as R10 windows. So what we're doing is saying when these new technologies are made available, we want to, in this roadmap, provide a pathway that we can, to use the illustration that Eric, the road for these types of emerging technologies through different demonstration programs, through different R&D, through, as I alluded to earlier, using laboratory facilities in combination with field experiments that Building America teams can do, coupled with WUFI and moisture modeling simulation.
Thank you. And now I have some questions for Ian on indoor air quality. The roadmap mentions that you plan to develop a system of IAQ scores for homes, similar to HERS rating scores. Please tell us more about this.
Yeah, basically the bar we sort of have to doing anything with IAQ is when you go to a house, you don't know if it has good IAQ or not. And like we didn't know much about the energy use of homes many years ago, we're sort of a long way behind with rating IAQ. But we think we do know enough to produce some sort of score that would give us reasonable guidance on whether or not you have a home that's performing well from an IAQ perspective. This includes looking at ventilation systems, other air cleaning systems. Are there source control options? For example, you can select construction products that emit less pollutants. Do you have an automatic exhaust system in your kitchen, for example? And this also includes issues about combustion safety and also the ability to deal with outdoor pollutants. Sometimes if you live in a place where the ozone is high periodically, you might want to ventilate less when ozone is high. or if you live near a freeway when particle levels are high outdoors. So the idea is we can combine all of these different aspects that would affect the indoor air quality in your home and generate a score. And similar to the way you get a score for energy, we would have some diagnostics for some of these things, like making sure that if you have a ventilation system, it actually does have the right airflow. And we would combine these diagnostics with calculations of the different health impacts of different pollutants and their relative prevalence and the systems that are home to deal with them. And hopefully we can come up with some sort of score that lets us evaluate a home and rate homes relative to each other.
Okay, thank you. And another question for you, Ian. Recently I read about LBL's Range Hood Roundup survey in the monthly Building America Update newsletter. Will you use the results from this survey in your research?
Absolutely. Again, this is an issue where if only we knew how everybody cooked all the time, we'd be able to put standards together that use that information, but we don't. And we do have limited data from our collaborative activities with various manufacturers of kitchen venting equipment. But the Range Hood Roundup is a way for us to basically get a bigger sample of what people do when they're cooking. Do they use the front or the back burners? Do they ever even turn on a range hood on? Do they have a range hood at all? And if they have one, why do they use it? Why don't they use it? There are issues about how noisy the fans are, for example. And some range hoods work better than others. Some have really, really good capture of the kitchen pollutants and some don't. And one of the things that we're going to use the information from the survey in is in the development of a standard to rate range hoods for capture efficiency. And if we know how often people use front or back burners and how often they cook, we can use that information when we're developing the test conditions for the capture efficiency standard. And so we'll be using the information from that survey directly in our research work and in standards development.
Okay, and then I have another general question here for Eric. Does the roadmap strategy include innovative energy storage systems?
Sorry, I was on mute. No, it doesn't at this point. I think the answer, the expanded answer is similar to what Rod is saying about R10 Windows, for instance. We would like to be able to consider innovative ways to getting to high performance home levels in the marketplace consistently, realistically, in a way that manages all the risks that we've talked about, and as innovatively as we can, and as affordable new products come online that helps us to deliver on those goals. We're going to want to be open to all of those kinds of things. Energy storage is one of those issues that currently it needs a little bit of earlier stage research support to get to a point where we're going to be willing to adopt it, as an off-the-shelf technology in Building America. I mean, Building America, unlike some of the other research investments that we do at DOE, it is primarily focused on the system level optimization, which means taking existing equipment and materials and putting them together in as optimal a way as possible, considering not only the technical issues but also the business issues and market infrastructure issues. So specifying a new transformative technology that we think might have some significant future impacts, it is not our sweet spot, but as soon as it starts to get close to market introduction phase, we're going to look closer at it. So I guess the way I would answer that is, in that context, a couple of years from now, I imagine things will have changed and that we'll be ready to revise the roadmaps, and maybe that'll mean including storage, consideration for storage technologies. and maybe we'll have R10 windows that are ready to be part of the objectives of the roadmap. So this is going to have to be a dynamic process as we go forward. If we don't revise it as the field changes, then we'll be outdated before too long. So.
All right, thank you. And that's all the time we have for questions today, but we will have all of the questions that were submitted on record for our group to review. And now we would like to ask our audience to answer 3 short questions about today's webinar. Your feedback will help us to know what we are doing well and where we can improve. The first question asks whether the webinar content was useful and informative. To answer, click on the radio button right in the Go to Webinar panel. And the second question asks about the effectiveness of the presenters. And the third question asks whether the webinar met your expectations. Thank you for taking our survey. The May Building America webinar, Resolving Codes and Standards Issues to Energy Innovations, will be held on May 20th and is open for registration now. Visit the Building America meetings page to sign up. Also, you can subscribe to receive notices about upcoming webinars and other news at the URL on the screen. On behalf of the Building America program, I'd like to thank our expert panelists for presenting today and our attendees for participating. We've had a terrific audience and we appreciate your time. Please visit the Building America website to download a copy of the slides and learn more about the program. We also invite you to inform your colleagues about Building America resources and service. Have a great week, and we hope to see you again at future Building America events. This concludes our webinar.